Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The compound is a 6-membered ring containing one oxygen atom and one NH group. Attached to the ring carbon between the two carbonyl groups is an acetyl, CH3-Co substituent. Moving on to the next step. Identify functional groups present. Ketone, the acetyl group, CH3-C, is equal to O-. Attached to the ring carbon is a ketone because the carbonyl carbon is bonded to two carbon atoms, the methyl and the ring carbon. Present. Ester, the ring contains A, C, is equal to O linkage, lactone, where a carbonyl is bonded to the ring oxygen. This is a cyclic ester, lactone. Present. Amide, the ring contains A, C, is equal to O, NH linkage, lactam, where a carbonyl is bonded to the ring nitrogen. This is a cyclic amide. Present. Ether, an ether requires a COC linkage where neither carbon bears a carbonyl directly making it an ester. The oxygen in the ring is part of the ester, C is equal to O, CH2, so the O is part of the ester lactone functionality. There is no simple ether, COC without an adjacent carbonyl on the same oxygen present in the molecule. Moving on to the next step. Why ether is not present? In the ring, the oxygen atom is flanked on one side by a carbonyl carbon, making it an ester oxygen, and on the other side by a CH2 group. Because this oxygen is directly part of the ester linkage, it is classified as an ester, not an ether. No separate COC ether group exists anywhere in the molecule. And for the final step, why other options are incorrect? Ketone, A, is present via the acetyl substituent. Ester, B, is present via the lactone in the ring. Amide, C, is present via the lactam in the ring. Therefore, the correct answer is D. Therefore, the correct answer is option D.